Good morning and welcome to Mission Control Houston. We're inside the International Space Station Flight Control Room. This team is following along with the activities of the Expedition 29 crew members on board the space station. The crew members are working through the early afternoon of their day on board the station, working on various science experiments today. The crew includes Station Commander Mike Fossum, cosmonaut Sergei Volkov, and Japan Aerospace Exploration Agency astronaut Satoshi Furukawa. Some of the experiments they've been working on include one that is studying the maximum oxygen uptake for crew members on board the space station. It's called VO2 max for short. It's also sometimes referred to as VO2 peak. It is the standard measure of aerobic capacity and is directly related to the physical working capacity of an individual. And Station Commander Mike Fossum participated in that earlier this morning. He and flight engineer Satoshi Furukawa also participated in an educational payload called Education Payload Operations Demonstrations, where they occasionally record video with educational content about life and working on board the space station. Today's recording was about how the astronauts sleep on board the station. Those demonstrations have been a successful education program for the space station, allowing NASA to produce the physical properties such as force, motion, and energy in a microgravity environment. And those are different than what are observed on Earth, where gravity exists. And those video demonstrations are being made available online through the NASA Education Project and Central Operations of Resources for Educators, or core.nasa.gov. That's CORE.nasa.gov. Some of the other work involving an experiment is what we see here with Mike Fossum inside the station, working to open the combustion integrated rack to swap out a component in that for the continued research inside that rack. It is used to perform combustion experiments in microgravity. The one that has been operating in it is called FLEX, the Flame Extinguishment Experiment, which uses small droplets of fuel to study the special burning characteristics of fire in space to help with fire extinguishment technologies in the future. Another experiment being conducted on board the station is by flight engineer Sergei Volkov in the Russian segment called a Coulomb crystal, dynamic and structural characteristics experiment with the Coulomb systems. Coulomb systems are structures following Coulomb's law. It's a law of physics describing the electrostatic interaction between electrically charged particles, which was involved in the development of the theory of electromagnetism. The crew members also worked together inside the Russian segment. Volkov and Furukawa did a test of being able to send high-quality video, or MPEG-2 files, from the Russian segment of the station using the network of laptop computers on board the complex. An experiment running without interaction from the crew members right now is a capillary channel flow experiment that needs interaction by the crew members to change out components every once in a while, or samples, and that runs autonomously and is monitored by the team of scientists and engineers here on the ground. That experiment is studying how capillary flow is different in space, and hopefully to use that information to enable the design of spacecraft tanks that can supply gas-free propellant to spacecraft thrusters, greatly cutting cost and weight while improving reliability. Currently, spacecraft fuel tanks rely on an additional reservoir to prevent the ingestion of gas into the engines during firing. The experiment is testing the theoretical predictions for the free surface shapes and critical flow velocities for open capillary channel flows in microgravity. This is video being sent down from the International Space Station of that capillary channel flow experiment. It is streamed real-time to scientists here on the ground to monitor. The experiment is designed to validate the assumptions used to develop the governing equations of capillary flow. The experiments provide the verifications for the flow rate limits and corresponding critical flow velocities. And by understanding capillary fluid flow rates in microgravity, hardware can be developed for pumping liquids from one reservoir to another without the need for an actual pump with moving parts.